Today I'm going to illustrate how mathematics can be found everywhere and how we can understand difficult concepts using very simple games. Here is a game which children play all around the world. It's snake and ladder game, and here you roll a die and you move from square to square based on the number you get on a dice. And if you get to a square where there's a ladder, you climb up, or you can get swallowed by a snake. And here the goal of the game is to finish the board and reach the 100th square here. Now this game shows basic principles behind how web search engines work. If you were to consider these squares as web pages and you are moving from square to square using hyperlinks, then essentially it's the same process which is occurring. Here I have a Lego toy right here, and suppose this toy is at square number 52. This toy represents a web surfer who is surfing the internet using hyperlinks and in a probabilistic manner. So when I roll a dice here, this dice has letters, but I have marked them with numbers here. So when I roll a dice and I get a 5 here, then I move this toy or web surfer 5 squares. So the web surfer moves to a web page associated with square 57. If we were to play this game forever, which basically means that we keep on rolling the dice and moving this toy, and suppose we change the rule of the game that if you are at square 99, you can go back to the beginning of the game in a circular fashion, then you can keep on playing this game forever. Then what you will find that certain squares are being visited much more frequently than others. So it could happen that square 64 is visited more frequently than, let's say, square 43. In web search engine terms, you would say that web page associated with square 64 has higher rank or greater popularity than the web page associated with square 43. So let me illustrate this using a simple example here, because it will take us a while to play the game here if there are 100 squares. So here is a smaller version of the snake and ladder game with only 9 squares, and if we were to start here at square 1 here, and if I were to roll the die, so it's 6 here, 1, 2, 3, 4, 5, 6, and I note down here which squares are being visited. So we visited square 1 and then 7, and then there was a snake which swallowed, so it's back to square 1, and then I roll the dice again, and then it is 5, 1, 2, 3, 4, 5, so square 6, and you climb up the ladder to 8 right here, and then 1, so 9, 6, 1, 2, 3, 4, 5, 6, 6 and 8. And now you can see that we can now compute the probability of visiting a square. So this has to keep on going really to determine the probabilities. But here we can see that squares 6 and 8 and 1, they got visited twice. So they are more popular than squares 7 and 9. So their rank is higher. So this simple game illustrates the principle behind PageRank. This is a book written by mathematicians. So PageRank is used by Google's search engine. And if you were to look at this book, it uses really very advanced mathematics, linear algebra. But the basic idea is very simple, which is a snake and ladder game. And you can show this snake and ladder game in form of a graph. So these circles here represent the squares, and the edges are transition between squares. And as you're playing the game, basically you traverse this graph and you find yourself visiting certain web pages or squares or these graph nodes much more frequently. So if you were to traverse this graph in an infinite playing game, then we can compute these probabilities. Fortunately, linear algebra provides us a shortcut way of computing these probabilities. So you convert this structure into a probability matrix, and you can then apply linear algebra, especially Markov chain theory, in order to compute the page rank or popularity of a particular website. And here I will show you what exactly I mean by surfing. So here is Yahoo News web page. So if I'm a random surfer, I may click at any of these links. It's just full of links here. So this is like a square in a snake and ladder game. And for example, I can go to Reuters web page here by clicking that hyperlink. It's like moving from one square to another square. And then I'm in this square, and then I can click at any other link here. For example, I can click at this link and it takes me to Associated Press article, and that's what a web surfer does it in a random fashion. And if one is just surfing in a random fashion, you may find that certain websites are getting visited much more frequently. For example, CNN.com or Reuters or Associated Press will have high page rank or high popularity. So in a nutshell, mathematics is everywhere. It is fun. It is found in simple games like a snake and ladder, which is played all across the world by children. And such simple examples can describe basic idea, the essence of advanced mathematics, and very useful practical algorithms such as PageRank. Thank you.